Welcome to this explainer. Now, if you think the ground beneath your feet is solid, permanent, and unmoving, well, we're about to completely shatter that illusion. Today, we're diving into the science of our planet to discover just how incredibly dynamic our world really is. Here's our roadmap. We'll start by redefining what a continent actually is, dive into the tectonic engine that builds them, and then take a quick, massive tour through the Americas, Eurasia, Africa, and finally the extremes down south, Australia and Antarctica.
All right, section 1. What are continents really?
So, I want you to ask yourself, where does a continent actually end? You look at a standard map and it's super tempting to think the coastline, where the beach meets the water, is the edge. But geologically speaking, that coastline is literally just a waterline. The true boundary is actually hiding right there underwater. It turns out the actual borders of our landmasses extend way out into the ocean, along what we call the continental shelf. Because this gently sloping area defines the true physical boundary, those 7 major divisions of land we all learned about are actually much, much larger than their visible coastlines suggest.
Which brings us to section 2, the tectonic engine.
To really wrap our heads around this, we have to jump way back into deep time. The oldest continental pieces formed around 4 billion years ago, and they're constantly wandering. By 240 million years ago, continuous tectonic activity had smashed them all together into one massive supercontinent. But then, about 200 million years ago, the exact same forces that built it started tearing it right back apart.
So what's driving all this? It's powered by a tectonic engine, specifically a violent, fiery process called subduction. Picture this. Heavy oceanic crust slides beneath another plate. As it sinks, the intense heat of the Earth's mantle literally melts the rock. That magma then rises, bursts out as lava, and when it cools down, boom. It hardens, eventually building brand new volcanic islands and massive continental landmasses.
Now, you might be wondering, why don't the continents just sink into the mantle too? Well, oceanic crust is heavy, so it's constantly being pulled down, subducted, and recycled. But continental crust is a whole lot lighter. It basically just floats and rides on top. That's exactly why continental rock is so much older than the rock at the bottom of the ocean. Let's move on to section 3, the Americas. This fact completely redefines our sense of geography. North and South America were actually completely separate landmasses for almost their entire history. No connection whatsoever. They only crashed together at the Isthmus of Panama a mere 3 million years ago. Geologically speaking, that is practically yesterday. Both of these continents share some amazing features. You've got young, highly active volcanic mountains on their western edges, pushed up by grinding tectonic plates, think the Rockies and the Andes. They boast incredible biodiversity, from the vast Amazon rainforest to the massive California redwoods. And their human geographies are just incredibly rich. North America alone is home to over 500 indigenous nations, like the Inuit and the Iroquois. Down in South America, indigenous groups like the Yagan and the Guarani have shown remarkable resilience, successfully maintaining their cultures despite the devastating historical impacts of European colonization. Let's head east for section 4, Europe, Africa, and Asia. It is super fascinating to realize that, geologically speaking, Europe and Asia are a single, continuous piece of land. They are one. The historical division between them isn't some deep physical boundary. It's driven entirely by human perception and cultural differences. And speaking of humans, the sheer number of people living on these landmasses is absolutely staggering. Look at this breakdown. Asia alone holds a massive 60% of the global population. Africa adds another 18.3%. That means nearly 80% of humanity resides on just these 2 interconnected continental areas. Wild, right? These regions are a study in extremes and deeply complex histories. In Europe, having easy access to oceans and navigable rivers drove incredible wealth, which ultimately fueled global colonization. Meanwhile, tectonic forces in Africa's Great Rift Valley are literally tearing the continent apart. The historical weight here is immense, too, including the transatlantic slave trade, which violently kidnapped over 12.5 million Africans. Across all these lands, indigenous groups like the Maasai in Tanzania or the Hmong in Asia are continually fighting for their autonomy. And geographically, Asia pushes the limits, holding both the highest peak on Earth at Mount Everest and the lowest point on land at the Dead Sea.
Oh, and remember that tectonic engine we were talking about earlier? It is still running full throttle. Right now, as the plate carrying India violently smashes northward into Eurasia, Parts of the Himalayan mountain range literally grow 2.5 centimeters taller every 5 years. The map is literally alive.
Which brings us to our final stop, Section 5, the extremes, Australia and Antarctica. Comparing these two extremes side by side is quite striking. Australia is the second driest continent, famous for its hot outback. Antarctica, it is the absolute driest, windiest, and iciest continent on Earth, with temperatures plunging below -73 degrees Celsius. Australia is basically a hot coastal living laboratory packed with unique wildlife, while Antarctica serves as this freezing, uninhabited archive preserving Earth's climate history and ancient ice cores and meteorites.
Australia's story is just an amazing web of ecology and humanity. When it broke away from Antarctica over 60 million years ago, it sailed away like a giant ark, carrying a cargo of animals that evolved in total isolation, giving us unique wildlife like koalas and the platypus. Off its coast sits the Great Barrier Reef, the world's largest living organism. And alongside all this, Aboriginal and Torres Strait Islander peoples have inhabited the continent for tens of thousands of years, successfully resisting colonial harm to fiercely protect their cultures to this very day.
Down at the bottom of the world, Antarctica is a totally different story. It remains completely unpopulated by permanent citizens, it doesn't belong to any single country, and it is entirely governed by a 1959 multinational treaty. The whole continent is strictly dedicated to peaceful, scientific research.
And that brings us to our conclusion, the future map. If you take just one thing away from this explainer, let it be this. That world map hanging on your wall, it is just a temporary snapshot in Earth's deep history. It is not permanent, and it's changing right underneath our feet. We can see these tectonic shifts happening right now. North America and Europe are drifting about 1 inch further apart every single year. Fast forward deep into the future, and parts of California might actually snap off entirely and become an island. And over in Africa, the continent could completely split into 2 separate landmasses along the Great Rift Valley. So as we look ahead to the deep, dynamic future of our ever-changing planet, we have to ask ourselves, when Africa completely splits in 2, and as the oceans continue to widen and shrink, are we currently drifting right toward the next great supercontinent? Thank you so much for joining me for this explainer, and I hope you never look at a map the same way again.